Good morning students. Today we'll discuss more in detail about the chapter trigonometry. We have studied about the trigonometry, the identities, three identities we have studied, that is sin square theta plus cos square theta is equal to 1, 1 plus x square theta is equal to cos x square theta, and like all this we have studied. Now we'll go in detail. Now my next topic is trigonometric functions. Okay. Now my next topic is trigonometric functions. Let's go in detail and study about what is this. Okay. So see, I'm just making one thing. Okay, that is OAP. Initial ray, terminal ray. Okay, that is what we got. That is initial ray and terminal ray. So we can easily identify what I am talking about is about the angle. What I am talking about is about the angle. So now in this we can see that I have made two figures. Okay, that is now I am trying to make angles. That is the initial ray, that is the terminal ray. Okay, so if the angle is the amount of rotation, is the measure of rotation from initial to terminal ray. Okay, so if it is moving anti-clockwise, then we can say this angle is positive angle. Okay, if it is moving clockwise, then we'll say it is a negative angle. Okay, negative angle. So these two things which are important now. Now we'll talk about more is the degree and the radian. These degree measure and the radian, these are the two important topics now. Okay. So now what is about, let's talk about how to measure angle, or you can say amount of, in how the amount of rotation from its initial point, that is called angle. Now we'll say measurement, like see, that is 180 degree. Okay, that is 180 degree. So we can make like this. Okay, that is the initial ray and that is terminal ray. Okay, or you can take like this also, 360 degree. Okay, from initial to that is terminal. Okay, terminal. So you can see 180 degree, 360 degree, that's the amount of rotation from initial point. So we can easily measure the angle. Okay, now that is what we have already, I have shown you about the degree. Now what is degree here? what is degree measure? Degree measure is the amount of rotation from initial point to the final, that is the initial point, initial ray to the final is the 1/360th of revolution. Revolution. That angle is said to be, angle is said to be 1 degree. Now 1 degree is divided into minute. 1 degree is divided into minute, 60 minute and 60 seconds. How? We can say the amount of rotation. Now 1 degree is divided into 1/60th of 1/60th of minute, okay, and 1/60th of, that is degree, 1 degree, okay, a 60th of minute. So we can say 1 degree is equal to 60 minute and 1 minute is equal to 60 seconds. So that is how we can use them in numerical. Okay, so this is the degree measure, that is the amount of rotation from initial point of view is the 1/60th of the revolution. That angle is said to be 1 degree. Okay, so 1 degree is further divided into 60 minutes and 60 seconds. That is 1/60th of the minute and 1/60th of the this 1 degree. So what we got? 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. That is how we can show in that case. Okay. So now that is what we have studied now is degree. Now let us talk about radian. What is radian? And later we'll talk about the relationship between them, degree and the radian. So now, what is radian here? We'll show by diagram so that easily you can identify. Oh, okay. So that is, if I say theta, that is L, that is R. Okay, so we can say that the radian is the angle subtended at the center by an arc of a length L having radius R. Here I can find the value of theta also, that is L upon R. Okay, I am telling directly, or else I can also depict like one radian. If I define, okay, if I define 1 radian here is how that when an arc of 1 unit subtends an angle at the center of the circle of a radius of 1 unit is called the angle 1 radian. Okay, so that is called the 1 radian. Okay, so that is how we can define about this. If I have taken theta here is the angle and L is the length of the R and R is the radius, so we can easily calculate this value among these three. If 2 is given, like theta or radius is given, or length is given or radius is given, we can find the theta. Okay, and vice versa. So we can find like this. Okay, so this is a degree and that is the radian. Okay, so now that is what we can find easily. Okay, now more thing is we need to discuss about is what is the relation between degree and the radian. Okay, so what is the relation between degree and the radian? Let us see. Now I hope it's clear to all of you. That's what is the base now, how we can say that it is a degree and how we can say it is a radian. Okay, now we'll talk about when a circle, okay, when a circle is there, now let's take its center O. You can see when a circle at the center is made with center O and the angle here is radian, that is 2 pi, is total makes an angle of 360 degree. So we can say 2 pi is equal to 360 degree, or pi radian we must use here is 180 degree. So we can say 1 radian is equal to 180 degree upon pi, and 1 degree is equal to pi upon 180 degree. Okay, so that is how we can take the relation between degree and radian. Okay, you can take a relation between degree and the radian. Now, for examples, by example we can easily understand what they want to ask. Okay, for example, I am taking one example. 6 radian is given. Okay, and we need to convert it in degree. We have just learned about that pi radian is equal to 180 degree. So 1 radian is equal to 180 degree into pi. So 1 radian is equal to 180 degree upon pi. Okay, and 6 radian is equal to 180 degree upon pi into 6. So we all know that the value of pi is 22/7. We have used in previous classes, so we'll use here also. So here 180 upon 22/7 into 6. So if you multiply 1080 into 7 upon 22. Okay, so that is how, if I divide this, I got this, how it is done. Okay, so we can say I will find, if I multiply with this, so I got what I will tell you. Okay, now we can see, if I divide this by 11 and I got here 540. If I divide this, I got 49. So if now I got 49 into 7, that is 343 point 63. Okay, so that is what I got all in degree. Okay, so this is what they have done. Now this is an example how to convert radian into degree. Now one more example, if we can see, to convert degree into radian. How? Let us see. We can, okay, let's move all this now. How to convert, we all know now. Okay, so let us take one more example now. Okay, one more example is convert 40 degree 20 minute into radian. Okay, into radian. Now we have just seen, we have just seen about that. If I convert this, we have seen that pi radian is equal to 180 degree. Okay, now we need to convert it into radian, so I will write this. 180 degree is equal to pi. So 1 degree is equal to pi upon 180. So I need to multiply this 40 degree 20 minute is equal to pi upon 180 into 40 degree 20 minute. First of all, now I need to convert this in degree. Okay, as you all know, 1 degree is equal to 60 minute. Okay, so I can say 60 minute is equal to 1 degree. 1 minute is equal to 1 degree upon 1 upon 60, and 20 minute I need to convert it. So I will show like this. 3. 1 by 3 degree. So now I can write this. Like I can write 41 upon 3. This is not total. So I can multiply, because now it is in mixed fraction. So we'll convert it. I'll got this. Okay. So now I can insert this value here. So pi upon 180 into 120 upon 3. Okay. So now I can then easily say this 121 pi upon 180 into 3, that is 540. Okay. So now it will be in. Okay. It will be ready now. You can further sort it out if you need to sort it out, but okay, if I say this 11, if I divide this by 11, it's possible. Yeah, 11, 4, left to 10. No, you will not get straight answer. So instead of, we can easily put it like this. Okay. So just we have seen that how to convert degree into radian and radian into degree. Okay. So now we'll try to solve more examples, because we have just seen the formula for the radian, but we have seen angle theta is equal to L upon R. Okay. So this now will apply in next example. Now we have two numericals, that is the radius of the circle we need to find, in which a central angle of 60 degree intercept an arc of length this much, and the minute hand of a watch is this much. How far does its tip move in 40 minutes? Now we have two numericals regarding this. Now we'll use this formula. How? See what they're asking about radius. So we need to do like this. Now R is equal to L upon theta. Now you can see here, to need to find the radius. Now we have L, that is 37.4 centimeter, but radius, but angle we have 60 degree. So first we need to convert it into radian. Now 60 degree, we all know 1 degree is equal to 60 minutes. Okay, but no, this will not be applied here. We'll see how to convert it in radian. Okay, we have seen that 180 degree is equal to pi radian. Okay, so 1 degree is equal to pi upon 180. Now 60 degree is equal to pi upon, now see, 60 degree is equal to pi upon 180 into 60, that will be in radian now. Okay, so I got this pi upon 3. So pi upon 3, so I will apply here now. This value will, now see how we will write this value. Pi upon 3 here, using this, is equal to R. So R is equal to 37.4 upon theta is pi upon 3. So 37.4 into 3 upon 22 upon 7. Okay. So now I got this value. Instead, okay, it's very easy. Take 7 also there. So 37.4 into 3 into 7 upon 22. So now we can easily find its value. How? Just multiply it into 21 upon 22. Okay, so after later on we can multiply this and try to find a value. If I divide by this, okay, but that is 1, 11, 7. So I got this. Now multiply with this. We'll got what? If I multiply here, 21 into 17, 35.7. Okay, so that is how we can easily find the radius. We are finding radial value, that is 35.7 centimeter. Okay, let's hope it's clear now. Now we'll move to the next question. That is, a minute hand of a watch is 1.5 centimeter long. How far does it move in 40 minutes? Okay, so let us see how we can try to solve this numerical. See, the minute hand of a watch is 1.5 centimeter long. So it means we have radius. Okay, we have radius. Now, how far it moves in 40 minutes? We already know. Now, we need to find this theta so that we can find L. So now, what I have given is how to find theta is, let us first see, in 60 minutes. And minute hand, it completes one revolution. In 60 minutes, it completes one revolution. In 1 minute, 1 upon 60 revolution. Okay. Now, in 1 minute, we have 1 upon 60 revolution. After 1 minute, now we need to calculate for 40 minutes. So 40 minutes will be 1 upon 60 into 40. So I got this. Okay. So I got this 2 upon 3 of the revolution. That means in complete revolution it moves 360 degree. So I got this 2 upon 3 into 360. So I got 240. I got my theta 240 degree. Okay. So I got this 240. Because they are asking about this. Now we need to find the L. So how we find L? Theta into R. That is, what is theta? 240 into what is radius? 1.5 centimeter. Okay. So we find that theta is 240 degree. Now we can easily calculate this by value, but we need to find again, I think, that is 240 degree now in terms of pi. So what we can do is, let's calculate again. What I have done is 180 degree is equal to pi radian. Okay, so 1 degree is equal to pi upon 180 and 240 degree is equal to pi upon 180 into 240, so that we can convert it in radian. So I got a value (3 pi upon 4). That is 3 pi upon 4 radian. So now I can put here 3 pi upon 4 into 1.5. So now easily I can calculate. Okay. So now see, it's given pi 3 pi upon 4. We can use here pi value is 3.14 because already it is given in decimal form. So now I can easily find the distance by how? By dividing it. Okay. So I got if I did this into 10, It's a small tricks to to calculate, or you can also add this. Okay, so now I got this. So now what can I do is 2 t. Now I can do is 9 into 157 upon 400. Okay. So now I can easily calculate this. Now what I got is 9 into 157. So 157 into 9, 1413. So 1413 upon 400. Okay, so that is how we can now easily calculate the value, that is okay. So I can easily calculate this value. So I finally got my answer, that is by dividing this I got 3.5%. Okay, so finally find the distance, that is how far it is the tip moves in 40 minutes. Okay, so that is how these questions are asked about theta, that is L upon R. Okay, now I have one more example, more interesting example regarding this. Then we'll move to the next topic. We'll make this chapter more interesting, as this chapter is very interesting, and for present purpose also and for future purpose also. Now I have two arcs. Okay, both have same length. Okay, they subtend an angle at the center. Now they are subtending an angle at the center. It is 65 degree, and here it is 110 degree. Now they are asking about to find the radius ratio. Okay, we need to find the ratio of the radius. Now we can see to find the ratio of the radius, we need to now see how to calculate it. See, L is equal to theta 1 R1 is equal to theta 2 R2. Now we need to find the radius ratio. How to find it? That is theta 2 upon theta 1. Okay. So we have two arcs of same length of two circles. They are subtending different angles at the center. Then the question is asking to find the ratio of the radius. So we can calculate like this. But the thing is, we need to convert them in radian. How to convert it? We know that we have done that 180 degree is equal to pi radian. Okay, so 1 degree is equal to pi upon 180. Okay, so now 1 degree is equal to pi upon 180. So 65 degrees is equal to 65 pi upon 180 radian. Okay, and now we have that 65 degree, and with 110 degree is equal to 180 radian. Okay, so like this we can calculate. Now we need to apply this value here. We got theta 2 is just 1 pi upon 180 upon 65 pi upon 180. So 110 pi upon 180 into 180 upon 65 pi. So what I got is 110 upon 65. So 22 upon 30. Okay, I got 22 upon 30. Now I got R1 is to R2. 22 is to 30. See, now we can easily find the value, that is the ratio of the radius they are asking in the numerical. Okay, so now this is, we'll now move to further. We can solve more type of numericals in this, but now we'll move to the next topic we have, and that the topic is about this chapter only. Okay, and the next topic we'll discuss about this chapter only, this topic only. Okay, now the next thing we need to make this, lot of formulas will have now. Okay, lot of formulas related to find the value, like we know. Now we can easily identify, that is when we write 0 degree means 0, okay, that is in degree, okay, and if I say in radian, okay, how to in a radian, like 30 degree it will be pi upon 6, and 45 degree it will be pi upon 4, 60 degree we have pi upon 3, okay. Now further we'll move to the 90 degree, will be pi upon 2. So finally we can write this in radian, and more we can write in pi, that is 180. Okay, so I have written that pi is equal to 180 degree, and then after 180 degree we have what? This is 180. Then we'll move to a 270, that is 270, 3 pi by 2, and we have 360 degree, we have 2 pi. So now we can write these degrees in radian like this. Okay, so this is the most important part we have just discussed, that what value to be written in degree form and which value to be in this form. Okay, so now we can write degree into radian like this. So now we'll discuss more about we have. Okay, so now we'll see, we know that this is a quadrant. Okay, now this is a quadrant, that is 0, then we have pi by 2, we have here, we have pi, we'll have 3 pi by 2, then we'll have 2 pi. Okay, we have studied in 9th class about this quadrant, first quadrant, second quadrant, then we have third quadrant, okay, and we have fourth quadrant. Okay, we have learned about abscissa, ordinate, the x-axis, y-axis. We have studied in coordinate 20 in 3rd.